Okay, chapter 2.2, polynomial functions of higher degree. How do you sketch graphs of polynomial functions? We're all familiar with quadratics and sketching sketching a quadratic parabola. God, I couldn't think of the word parabola, but that it kind of fits for all of the polynomials. So let's just go through real quick. So basics of graphs of polynomials. All polynomial graphs are continuous. Okay, there's no like starts. There's no holes in them. There's no asymptotes. They're all continuous. Nice smooth curves. Okay, we don't have this kind of stuff. Okay, it's nice and smooth and continuous. All right. In behavior, what do we mean by the in behavior? In behavior, let's think of a parabola. Parabola usually opens up. The in behavior means that as our parabola, as our x values are getting greater towards infinity, our y values, our f of x, are also going towards infinity. It also means that as our x values are getting smaller, going towards negative infinity, the y values are getting larger towards infinity. So when we talk about the end value, we're talking about where is this going? Where is our graph heading to? All right, and there's some similarities or basics here in terms of all of our polynomials, and it all is based on the leading coefficient and the degree. So if we have an even degree, we're talking about x squared, x to the fourth, x to the sixth, all even degree polynomials. They're all going to do the same thing, and this is the same as what we just said with a quadratic, which is x squared, and that polynomial opening up. Okay, if a is positive, so a is positive, then it is opening up. Now, if it is a quadratic second degree, then it's our typical parabola. But let's say like it's not a quadratic. Let's say like it's to the fourth power. It's still, that ending behavior is still the same. It's just what happens in between those arrows. This part changes depending on the degree of our polynomial. But the end behavior right here, that behavior, that's going to be the same. That's going to be consistent with any even degree odd. So if it's an even degree positive a, then as x heads towards infinity, as x gets bigger, then f of x, or our y values, they also get larger, head towards infinity. And then as x heads towards negative infinity, gets smaller, f of x, or our y values, still continue to get larger. Okay, so again, that's our parabola where it's going up, it's going in positive direction, whether x is going positive or negative. Now, if a is negative, that's when we have our parabola facing down, right? So in that case, as x gets larger, as x goes towards infinity, our f of x, our y values, are heading towards negative infinity. They're getting smaller. And then as x heads towards negative infinity, gets smaller, f of x is also heading towards negative infinity. Right? Coming over here to our odd degree, so this is our x, x, not x squared, but x cubed, x to the fifth, x to the seventh. So this is, and you might be familiar with this with a cubic. A cubic looks something like that. Now, if it's x to the fifth, again, that ending behavior stays the same. It's just what happens in here changes. All right? But that ending behavior right here, that stays the same depending on two things. If the lead coefficient is positive, and then if it's an odd degree, like we said. So if a is positive and it's an odd degree, that's a situation where you see right here. Okay? So as x goes towards infinity, as x gets bigger, f of x also heads towards infinity. But as x gets smaller, goes negative infinity, then f of x also gets smaller, right? That's what we're seeing here. So f of x goes towards negative infinity. All right, now if a is less than 0, now we switch this. Okay, so this is if a is negative. All right. Okay, if that's the case, then as x gets larger, heads towards infinity, as x gets bigger, f of x is getting smaller. F of x heads towards negative infinity. And then as x heads towards negative infinity, f of x gets larger, heads towards infinity. Okay, as x gets smaller, our y, or f of x, is getting larger. All right, so those are the kind of key pieces here. Real quickly here on roots and factors, if x equals a solves a polynomial function for p of a equals 0. In other words, if we're solving it for this value here, then x equals a, that's when if we are asked to give the 0, we're going to write as x equals a. If we're asked to give it a solution, we write the same thing, a equals a. If we're asked to write as a factor, okay, so we have a 0, x equals a. As a factor, that would be x minus a. And then if we're asked to find the x-intercept, all right, that's going to be written as whatever a is, 0. So because it is an x-intercept. So this is just kind of highlighting the different ways you would write, because all of these are the same thing, okay? Zeros, solutions, factors, roots, x-intercepts, they're all the same. They all kind of mean the same thing. They're just written differently. Okay. Let's get through 1, 2, and 3, and then we'll take a break. Okay, so determine the end behavior of the polynomial. All right, well, first of all, I noticed that it is odd. I just covered it up. It is odd, it's a 5th degree. And then I also noticed that a is negative. So a is negative, is less than 0, and 5 is odd. Okay, so we're looking at this situation right here. So determine the end behavior of this. We know that as x is getting larger, right, our graph, our y, our f of x, is going to be getting smaller. So in other words, and as x gets smaller towards infinity, then our y is going to be getting larger. Or did I say, oops, made a mistake back here. This should be negative infinity, and that's infinity. So again, what that means is that in this case, our graph is going to look, now what's going on here, we don't know, but the end behavior, we know. Okay, find the zeros of this polynomial. So find the zeros. So x equals a. So we're going to go, oops, don't need that. We're going to say x to the 4th minus 4x squared equals 0. We want to solve for x. I'm going to factor out x squared. That gives me x squared minus 4 equals 0. I'm going to set each of these factors to 0. X squared equals 0. X minus 4 equals 0. In this case, x equals 0. And not to spoil it, but I'm going to mention this has a multiplicity of 2. Okay, because there's 2 of them. There's x times x, right? X squared, so that's x times x. That's x equals 0. X equals 0. There are 2 zeros there. So that's why x with a multiplicity of 0. Okay, erase this. Okay, and then on the other side here, we have x squared equals 4. So x equals positive negative 2. So find the zeros. The zeros would be this. It would be x equals the set. See, 0, 2, and negative 2. Okay, that'd be one way to write it out. There are zeros. Okay, if 3, negative 2, and 1/4 are zeros of the polynomial, find a possible equation for this polynomial. So what I'm going to do is I'm going to take each of my zeros, I'm going to write them as a factor. So 3, since, let's see, x equals 3, but we saw over here that to write as a factor, we would go x minus whatever that value is. So as a factor, I would write this as x minus 3. And x equals negative 2 as a factor, that would be x plus plus 2. And then x equals 1/4. We're not going, you could do x minus 1/4. I don't like that. I don't like dealing with fractions. So instead, what I can do is I could rewrite this as 4x minus 1. Because if we took that instead of equal to 0, that would be 4x equals 1, x equals 1/4, right? So we're just sort of deconstructing that. So those would be my 3 zeros, my 3 factors that were created by those 3 zeros. Now all I have to do is multiply these together. So f of x equals, let's go, this is x minus 3, x plus 2, 4x minus 1. Okay, so multiply this together, x squared minus x minus 6, if I multiply those together. And then 4x minus 1, I got to multiply this. So f of x equals, let's see, 4x cubed minus x squared. Let's see, I'm going to x, yep, minus x squared. And then negative 4x squared and positive x. And then negative 24x and plus 6. Now I'm going to simplify this, or consolidate everything. 4x cubed, negative x squared, that's negative 5x squared, right? Negative 1x squared minus 4x squared. And then x minus 24x, that's going to be minus 23x, and then plus 6. So that is find a possible equation. Now it said equation, I wrote it as a function. And the reason why it says possible is we're assuming that A is 1. And we'll see this later on where there's actually an A out here. In this case, that A was 1. And so this kind of fit like that. There could be other values here. So there could be other graphs with this same, other equations with that same one. All right. Should we carry on? No, we're going to take a break. We'll do another video.